Alrighty, so let's talk about Unity. I guess I can put this in presentation mode. Unity features you may not have known about. A workshop. So hello, my name is Taro Omiya, again, Executive Director of Tech Valley Gamespace, and I also make a lot of Unity games. And over the years, I kind of accumulated a bunch of these features that I happen to learn about on and off. But I haven't seen a whole lot of people actually talk about it as if they're like the newest and the greatest thing. So here I'm going to actually do that, give a little bit of, shine a little bit of light on things that you can do with Unity that you may not have known about. I am making the assumption that you have went through Crash Course in Unity or Crash Course in Unity 2D. You can find both of those lessons on techvalleygamespace.com/learn. And then if you scroll down a little bit, it should be right here, Crash Course in Unity 5 slides PDF. And then there's also scripting in Unity and making 2D games with Unity stuff. So I'm going to kind of zip ahead very quickly in regards to how to use Unity. I know a few of you are not familiar with that, so I'll try to kind of go over that as quickly as possible. But in any case, yes, okay. In any case, let's start off with how the default view looks like. These are, this project pane right here is basically anything that is inside your projects folder. If I could say show in folder, basically like post-processing, you can see this folder right here. Post-processing corresponds to this post-processing folder. Anything that's inside this assets folder in your project also will appear here, is the way it works. If you can click on different tabs, and that kind of brings up different menus. In this case, there's the console. We can ignore that. Hierarchy is a display of all the items that are inside the scene itself. Scene being any of these files that you see down here that has this little icon. The scene itself panel also displays any sort of scenes that you see. Like for example here, when I highlight over this little icon, it highlighted over the directional light. So this corresponds, this item corresponds to this directional light icon, and vice versa. And finally, the inspector displays the properties of that directional light. There's also the game panel, which is exactly what this camera right here sees. And we're going to disregard the asset store because that's not important at all. We're not here to buy things. So without further ado, I'm going to start off actually with something a little bit rudimentary, which is version control support. So for those not aware of version control is basically a Dropbox-like program that allows teams to sync their work together. The way that version control support works in Unity is that it gives you a couple of different options. When you go under Edit, then Project Settings, then Editor, it brings up on the inspector a couple of different options. And then you might notice that there's a thing called version control. You're going to want to set this to visible meta files. Once you do that, what will happen is that once you go back to your TVGS lesson with these assets, it creates these .meta files. This is actually super duper important. The meta files, which are text in this case, indicates what sort, how an item with the same file name is supposed to be imported. So that makes it easier to share information between multiple people because the how things are supposed to be imported can be edited, and that information can be edited by someone, and that information will be shared between people. I would also highly recommend under the asset serialization to switch to forced text. There is mixed and forced binary, which does create a smaller project size, but especially if you're working with multiple people, and especially if you're planning on scripting a lot, then you're going to want to use forced text because text is just that much better. Most version controls usually deal with text a lot better than with binary files. So that's really just it. After that, you can in this case I use Mercurial, but you can basically upload, push your project as necessary. I'm using 2017.3, which recently added this Unity Package Manager, but really the only folders that you need to add are assets, projects, assets and projects. Yeah, and then if you happen to be using the latest and the greatest, you'll also need to add in any files that are under the Unity Package Manager. You can completely disregard library and temp. In fact, if you do not disregard library, you're in for a world of hurt. But anyways, yeah, you can just get rid of library and temp. These files these folders are simply local and they're not useful at all in regards to sharing. All right, so that's the first thing, nice and quick and simple. And then the second thing is about prefabs. So let's talk about prefabs by opening this prefabs menu here. All right, cool. So we have the simple scene. These are all assets taken from the standard assets, or the built-in assets. You can import these by going under, I believe, game objects, no, assets. And then it says import package, and there's a couple of different packages that it lists out. I believe I imported 2D cameras, characters, and prototyping and particle system. So for anyone interested in those kind of things. Do I have Toon? No, I don't. Okay, so I did forget to import one thing real quick. Yeah, go for it. Not too worried about this for now. So yeah, sorry, I forgot to do that. So if you are following along, remember to go to import packages and effects. That's a package I forgot to import, my bad. We will need it for a later slide, but fortunately for this slide, not too important. All right, so in the meantime, while that's happening, if you have taken the Crash Course Unity course, you may remember that I mentioned that, let's say I'm going to add a cube here. So to create a cube, you can just right click on the hierarchy and then say 3D object and then cube. Here's a cube, looks nice. But you may remember that anytime I said you add in a new item, it is highly recommended to take that item and drag and drop it into the project so that it creates what's called a prefab. In this case, it created a prefab called cube. If you go to your TPGS lesson and then assets folder, you'll find that yes, there is now a cube.prefab file. But what does this mean? Like, why is this useful at all? Well, one thing you can do is you can now drag and drop this project cube into anywhere in the scene itself. So it's useful for being able to create multiple objects. But it's also useful for one other thing, which is that it allows you to kind of share information between all of these prefabs at once. So as an example, I have this prefab selected. If I were to say create a new material, and we're going to say this one is red, and then we say we want this color to be red, and then we can drag and drop that onto this cube right here. You might notice that only this cube has actually changed colors, but none of the others have. As it turns out, there is a button called apply under the inspector if you selected that cube, and if you click on that, it applies all that changes to other cubes that happens to be blue and also is of the same prefab as well. So, I mean, if I were to create a new cube right here, I don't know where that went. There we go. You might notice that's still white, and so if I were to then, you know, change the scale of this a little bit, like so, and then hit apply. This cube is not affected because it's not made from a prefab earlier, but all these other cubes are. So prefabs are super useful in regards to making sure that all the properties are kind of shared between each of these different items. But wait, there's more. There's a few other powerful things that you can do with a prefab. For example, if I wanted to add in a sphere and then make that the child of this prefab, make sure that that's zeroed in at the right location. and then this is plopped towards the top, and also applied a red texture. If I added in a child to this cube, and then I click on the cube and say apply to that, you might notice that that item now gets added to all of these prefabs. So that's really useful. I could also make it so that this far end of the cube, we're going to make it so that the circle right here is really, really tall, like so. But then I feel like, for this specific item, for this specific sphere, I kind of want it so that it's a little wider, like so. And then I say, well, let's apply it to this. Then you might notice that while the scale has been affected by all of them, this one still remains one of the tallest part. So what's going on here? When you click on this sphere itself, you might notice that this 2.6 text under the transform still remains a little bolded. This might require a little zoom in. Magnifier. Alrighty, this is useful. Frame rate. So right here, you might notice that the text that says Y 2.6 is bolded, but the other two scales are not. So I mean, this item right, the sphere right here, did in fact inflate a little larger, but other than that, only the 2.6 bolded text was the one parameter that remained unchanged. Basically, if you leave any of the parameters bolded, anytime something else changes, like let's say this, I changed that to 9, and then I apply that. If anything else changes, in theory, that value, the 2.6, remains unchanged. Any sort of bolded values remains unchanged. So you can actually kind of create like very specific exclusive enemies. Like if you imagine this from a perspective of enemies, maybe this is an enemy right here that you wanted to have extra large health, like 1000, and maybe give it a different color. Whereas these, they just have the same 10 base health. Then you can do so. And then if you make the changes to these items, then you can adjust the health to like 15 while leaving this super powerful enemy in the background right here completely unchanged. So that's like one way of creating a that's one convenience factor that Unity has to allow you to apply changes to multiple items at once. This also works in between different scenes as well. Like for example, in this camera scene right here, I'm gonna say that instead I want the cube to be taller, and then hit apply. And then if I switch to the prefab scenes, now you'll notice all the cubes are a lot taller. So, you know, again, it allows you to apply changes and allow you to send changes in information from one scene to another. Useful stuff. So, that's prefabs. Cameras. Okay, finally, we're getting to the fun stuff. So people who went to our 3D game design orbit group probably already knows most of these kind of things. But here we have a single camera. That's interesting. Why do I have that character? I accidentally swapped that out. Oh well, I'll worry about that later. So camera scene is not camera scene, but that's okay. I can take this out for now. So anyways, there's this character right here. If you play the game, you know, you should be able to slightly control the camera, but regardless, you can control the character using a WASD. Again, this is part of the standard assets. So on and so forth. You can kind of see that it is one of those perspective cameras. But yeah, cool stuff. So we have this camera right here. It's a multi-purpose camera rig. And then if you expand it and click on the camera, you get a bunch of property information. So there's a couple of really cool things that you can do here. The more obvious ones include the clear flags, which right now you can see in the camera right here. There's a camera view, remember. If you switch this to, say, solid color, of course it changes the sky color to just a solid color. If you switch this back to sky color, skybox, then again it will use the generic skybox that you can later adjust on a different scene. I believe you can do that via select project settings. And then graphics is the way I remember it. Anyways, there's a culling mask, which I'll go over later. And then finally, there's a perspective projection, which you can switch to from that to orthogonal. If people knows CAD a little bit, then you might recognize that orthogonal is kind of like a way to take out any sort of depth information. So now what you're seeing basically is what the camera would look like without any any vanishing points. Also, the reason why things are disappearing is due to the clipping plane, which is assigned right here. If something is 0.2 units away from the camera, it's not going to be rendered. Likewise, if it's if the far distance, if it's too far away, over 5,000 meters away, then it won't render that either. Field of view, as you would think, adjust basically the field of view. Let's switch that back to its original default 50. Orthogonal has the same value as well. But yeah, so those are the super duper simple stuff. But you might be asking, like, hey, how can I make this more useful? Well, you might notice that there's a couple of other parameters in here that you have no idea what this actually does. And that's a good question to ask, because as it turns out, a couple of these are really super useful. As an example here, if you want to create any sort of split screen, then it's just a matter of really creating a new camera. So let's duplicate this camera, plop it under the 3D controller so that it will follow it at all times. And we're going to just make it so that, oh, whoops, I do want to place this a little higher, 10 units. Rotation. We're going to have this camera, so I'm going to use this rotation tool and make sure that it's facing downwards. I may have overcompensated. Yeah, it looks like I have. Come on. There we go. Then we can take out this rotation. So now we have this camera perspective that is kind of looking from up down, right? And so we have a little bit of camera fighting here, but we're going to worry about that later. One thing that's really cool is that if you might see this viewport rectangle value, and you might be thinking, well, what does this do? For values that indicates where the screen, where on the screen the camera view will be drawn, measured in viewport coordinates. So as it turns out, if we change these values, like let's say 1 to 0.5 here, and then for the other camera right here, we're going to change that. We're going to have it start at 0.5 and make sure that the width is 0.5. Then right off the bat, we have literally a split screen perspective. Okay, it is not liking that. I know why it's not liking that. We need to change this new camera that we created and make sure it's on tag. Let's try that again. There we go. Much more like it. So now, I mean, the right camera is very wonky, but now we have this ridiculously crazy camera system where one side of the camera is displaying on the right side of the screen and the other camera is now being displayed on the left side of the screen. And so yeah, this is kind of nice. It kind of looks like you can make a radar out of this, and that is precisely what we're going to do next, actually. We can, in fact, create a radar system out of this system. because as it turns out, there's a couple of other variables on here that will be really useful for that purposes. We're going to go return back to the main camera and make sure main camera under the multi-purpose camera rig and make sure that that expands to the largest viewport. We're going to leave the depth value to -1. I'm going to talk about that later. However, in this camera, which remember this one is supposed to take up the right side of the screen, if you increase the depth value to say 1, it will now draw on top of the main camera, the 3D camera that we had before. As it turns out, the depth value indicates which order each of these cameras gets drawn on. The larger the camera is, the larger the number, the higher it shows up on the Z-plane. So we have this. So far, so good. Probably what we want to do with this camera is we want to shrink it a little bit. So let's switch the height to also 0.5. And then let's place it up in the upper right-hand corner. We probably want to shrink this width a little bit as well. Instead of 0.5, let's say we won't give it 0.3 and then offset it by a 0.7 area. So now we have this top-down view up on the upper right-hand corner. But wait, there's more. I mentioned earlier that we can talk about culling masks right here. This is super useful. Let's say right now we have this and we're like, I mean, this looks great and all, but how can we get it so that it's not displaying the floor? Or like, how can we get it so that this character right here is being portrayed by something else? I'm gonna actually focus on this character right here instead. And actually that is super duper simple. I'm gonna actually search for an icon right here. Oh, okay, this is useful. So here I can drag and drop, oh, it is the game view, that's right. You need to switch to scene view for this. I should be able to drag and drop this out. All right, that did not do what I think it did. Why did that not, oh, because this was not a sprite. Here we go. So we have a sprite. If you're looking for this, it's called button thumb stick up sprite, and then you'll need to expand this to get the actual sprite thing right here. So we have this. This is useful. We're gonna drop this under the third-party controller and then make sure that it's facing upwards. So here we go. And then you can kind of see an inkling of it becoming a radar system by having this sprite available here. We just need to figure out a way so that it's filtered so that the sprite doesn't appear on this camera and the character stops appearing here on this camera. And in fact, that's actually pretty simple to do. Also, this radar camera would probably benefit for being an orthogonal. There we go. And so the way you achieve that is by switching out between, setting the layers between each of these items. So for example, in this, we're going to, right now the layer is set to default. We're going to add a new layer and say, hey, I want this to be the character. And I'm also going to add a new layer right here called radar. And the idea is that anything that is marked as radar appears in radar only, and anything that is character only appears in the 3D game. We're going to click this third-party character again, and then switch this to character. It says, do you want to set all the layers of the character for a child object as well? I'm going to say yes. And then finally, I'm going to click on this button thumb sprite and switch this to radar only. So this right now starts the setup process for making sure that certain things are only visible on certain cameras. When you click on each of these cameras, one of these items is called culling mask. As it turns out, culling mask literally adjusts what is visible and what is not visible from the camera, and they are based off of layers. So in this case, I have main camera under the multi-purpose camera rig selected. So we just click on radar, and that makes the sprite disappear. even though technically it's still in the game scene right here. Under the camera, it no longer appears. Likewise, we click on the camera right here that's placed on the third person controller. We can get rid of, in this case, we can get rid of the character, and voila, now the character is no longer in the scene anymore. And that allows you to create a pretty rudimentary radar system. How is everyone following along so far? Pretty good? Alrighty. There are a couple of more interesting things you can do with cameras, and I will probably leave it off with this and switch up to the next topic. But one thing that I highly recommend doing is that once you have this multi-camera system, to play around with the clear flags. So if I were to set this to a solid color, obviously nothing happens. But if we switch it, and also I'm gonna, for demonstration purposes, also take this floor and change it to a character as well, so that it doesn't appear on this scene. So when I did that, because this camera's cooling mask takes out the character, it doesn't actually display that. And right now I switched it to solid color. And if I switch it to the skybox, it turns into this. But interestingly, there's a depth only property. And depth only, if there's anything that's supposed to be drawn in the background, completely takes it out. So here, so now you have this weird super transparent radar on the upper right hand corner, because that's cool. And you can do a lot of really crazy stuff by using the depth only. For example, a lot of tutorials will recommend that you use this. You use multiple cameras, with one of the cameras utilized for UI purposes, so that the UI always appears on top. This is a quick and easy way of basically making that UI layer happen. I did forget to mention one more thing, which is render texture. When you right click on the project pane, one thing that you might notice is that under the create, and then, where is it? Huh. Oh, here it is. Found it. Okay, so if you go to create, and then under lens flare and material, there's something called render texture. If you click on that, you'll create what's called a new render texture. Render. This is important because what you might notice is that on this main camera right here, there is an item that says target texture, and you might not know what exactly that does. As it turns out, the render texture, you can fill out a couple of information. We probably want to make this a lot larger than 256 by 256. I'm going to go for 512 by 512. And then one thing that interesting that you can do with render texture is that you can apply this, like it's basically like any texture. So you can apply this to various different items here. Let's put one on that. Let's put one on here as well. This created a new render material. That's useful, thank you. And then this is also on that render material as well. You can also just drag and drop these render materials. So far, like if I were to apply on these right now, all they do is they just appear dark. And if you were to walk around, yeah, well, all it does is it just appears like a dark thingy. But if you drag and drop that render texture that you just created under one of these fields, under target texture, then you might, this is probably a bad demonstration, but you might notice something a little different. Yeah, okay, this was a bad idea. Let me try that again. Let me duplicate this camera, and then let's drop the render texture on this camera. So by the way, if you're wondering what the heck just happened, I totally forgot that if you apply a render texture, then it basically disables that camera because it's now rendering on a specific texture. Anyways, now we can actually see this in action. Oh, that does not look good. Make sure that we take out depth only and make sure that's a solid color. Make sure that all the viewports are properly set up. There we go. So now it's viewing the whole thing. And you might notice that something really weird is going on the texturing on these cubes. Unfortunately, I do know why it's not looking great. That was a poor decision on my part. If I were to instead create a new quad, yep, let's drag that up a little bit. There we go. And then apply that render texture on that quad. There we go. You actually are seeing a bit of a hint right there. Notice that the quad displays exactly the same thing that's being rendered as the radar, plus the blue color right there. So render texture kind of allows you to create basically a TV screen. And in fact, let's make this extra trippy by creating a plane. Raise that up a little bit. There we go. Drag that out. And then we'll expand this. Whoop. And we'll make sure that this is only in the radar layer and not in anything else. We probably don't want it in the radar layer now that I think of it. Character layer. And then we're gonna drop that same render texture again. There we go. This probably created a new render. Yeah, it did. So I'm just gonna have a little bit of fun with this. Tiling 5. Oh, it doesn't really like that. Why does it not like that? Anti-aliasing. Oh, because it's clamp. Repeat. There we go. That should be a little more fun. So here it is. We have a TV as our floor. Yeah, I don't think a lot of people are gonna like this. We can also drop it right here at the same location as previous. Make sure that this is reset position and reset rotation. And then furthermore, we'll bring this back to normal perspective, and then we'll bring back the skybox. This only shows the radar, so we probably want to switch out the culling mask to character and nothing on the radar. Oh yeah, look at that majesty. So yeah, that's cameras and render texture. How am I looking on time? Okay, so far so good. So I'm gonna save this, leave that alone for now. Don't think too hard about it. But you can create more and more of these render textures if you wanted to. It's basically up to however much your graphics card can handle it. But yeah, in any case, let's move on to other things. Probably for another, I'm expecting to go on until probably around 9 o'clock. Audio reverb. So let's bring up the audio reverb. Okay, cool. So audio. Can we hear this volume? Can everyone hear that? Cool. So this is the, I'm using the normal first person controller, and you can kind of hear the footsteps and the walking and so forth. But let's say, you entered a cave and you want to hear a bit of an echo-like sensation. Echo is in comparison, a fairly difficult thing to do. There's a couple of tools that is made specifically for that purpose, but we can create what's called an audio reverb zone. And this can be done by simply going on right-click, say audio, and then there's an audio reverb zone. So here it is. It's basically just a sphere right here. You can already see it. I'm going to kind of shrink this a bit. So you can see here on the right side, it says audio reverb zone. We're going to make the minimum distance a lot smaller and a maximum distance also slightly smaller right here. So you can actually change the size of this using little nodes right here, but I like things done the hard way. So it kind of encompasses this range. Okay, cool. So, so far we created an audio reverb zone. I'm going to make a prefab of this real quick. And I should be able to add a couple more of these right on top of these cubes right here. And if you were to stand on top of these cubes, which is what these are for, just visual representation, you may have noticed something you may not have. So just to make sure everyone can hear that again. So it's almost like you're walking inside a hallway. But wait, there's more. Each of these reverb zones does have a couple of different items that you can customize. So as an example here, it says Reverb Preset, which right now all it does is it makes it sound like you're walking inside a hallway. But we can take this one, for example. We probably want to give each of these a different color so that we know what we're actually looking at. I'm going to use Control D. And then instead of red, let's call this yellow. Yellow is a bad color. Blue. I kind of regret using red because that's the colorblind unfriendly color. And then let's duplicate this. And then let's go with not green. Orange. A weird dark orangey color. There we go. So now that we can actually recognize the two, let's call this reverb zone normal. Let's call this reverb zone red. Let's call this reverb zone blue. Let's call this reverb zone orange-ish. So anyways, we already have the normal right here. Let's switch up the red a little bit. There's a couple of, when you click on the reverb presets, there's a huge number of presets that exists. Let's go with Dizzy, or yeah, Dizzy. So let's find out what that's like. So again, here's a sound effect for comparison's sake. This is the normal. This is the normal hallway sound, and then this is Dizzy. Actually, I can't tell the difference. Huh? Yeah, no, this is the right one. Yeah. And then the orange one is right here. So, and then blue, let's switch that to a cave. So it's a little more pronounced in the generic version. And then there's the orange one. Let's see. What is this plain one? Maybe it's softer? Presumably it decreases the volume, but I guess it's not very obvious to me what it's doing. I guess there's parking lot. And then we can actually change this on the fly. Let's see, underwater. Not sure what the difference between these sound effects are. I personally cannot tell. Auditorium. Yeah, it's coming from a projector speaker, so it might be far too subtle. But you can also adjust these just by simply going to off is not the right one I was looking for. User, there we go. At the very bottom there's user, and then you can adjust each of these parameters on your own. So let's say, for example, let's up the reflection, reduce the reverb, and then make the decay time really, really slow, and then the density really high, and let's see what happens. Oh, there's a reverb delay. Let's make that super high. Not that different. I do confess I don't really know much about the reverb zone, these parameters themselves really well, but I do know enough to obviously create like hallways and make it clear that you're inside sewers and so forth. So I hope that this is kind of like a useful way of creating sort of like an ecosystem inside your game. And of course, if you want to make it so that your character is always in the some sort of location, some sort of reverb location, you can always just drop the reverb zone on the character itself. And doing so, it'll always sound like your character is inside a hallway. This is of course more dependent on what level you're in. But yeah, that's reverb zone. It's actually really cool stuff. 2D effectors, we're gonna go into 2D. So I actually went over ever so briefly in regards to 2D effector related stuff. In that if people recognize, oh by the way, you can click on this to kind of make it 2D right here. In that if people remember what I did in the Crash Course 2D course, one of the effectors that you can drop in, there are a couple of platforms here. I'm going to select this platform and then say add component. And then when you go to add component under physics 2D, I believe, oh no, yes it is right here. There's something called like a platform effector. This effector will not function until there is at least one 2D enabled collider with used by effector on the game object. Thank you for that. And then we're going to change this collider to say used by effector. This collider will not function with the effector until there is at least one. Oh, I dropped this on the wrong place. Let's copy that and remove it from here. Excuse me. So what I meant to say is if you selected on this platform, then clicked on its collider right here, then added this platform effector, then you might recall that by doing so, you can now jump through this platform, rather than normally for these platforms, you just bonk your head on. Looks like I need to actually drop all of these platforms a bit. So let's do that real quick. There we go. So again, bonk, and then again, jump. The reason why I bonk my head on the edges is because there's actually a collider on each of these edges. yeah, there's a very small collider. You can faintly see it right there on each of the edge of the collider, which is just how these platforms are made, but you can easily get rid of those. So yeah, here's the jump through 2D effector. But there's actually a ton of different effectors in Unity itself. So for example, if I click on this and then click on it again, it'll say these are all the colliders. But anyways, this is a collider object right here. And you know, we can select use by effector and then add component. There are a couple of different effectors under Physics 2D that you might notice, including, for example, there is area effector, which I believe is water. The force is that use a global angle, force angle, magnitude, force target, variations. So in theory, oh, interesting. I think you need to pull on is trigger. Yeah, it should be checked when using an area effector, so I didn't read that carefully. And then let's make this force magnitude 1000 to make it extra obvious. There we go. See that? So this is kind of like a neat way of creating an area where you're constantly being blown in one direction or the other. You can obviously change the angle. So I believe this angle is based off of right is 0 degrees and down is 9 degrees. Oh, okay, wrong direction. Come back. So, whoops, that was a bit much. 90 degrees again, let's play that. There we go. So this is kind of like an easy way of creating water. Yeah, let's make this a particularly tall platform right here. And then we can kind of drag it down a little bit. We can also get rid of these sliders here too. Those are not useful. Boop. Yoink. So yeah, you have this weird water-like effect going on. And you might also notice that in doing so, there is a collider mask that allows you to decide what actually gets collided into this effector and what gets affected. So that's one way of doing that. There's damping, interesting. So if you want to like really create a water-like effect, so rather than rather than applying any sort of force, we'll add in like a 10 force, but we'll also make it so that the drag is super duper large. Then when you try to walk in, you kind of fall really slowly. Now the reason why the character itself moves really, really fast, despite that, is because I believe the script on the character itself is based off of velocity. So the velocity of the character is being affected directly. If instead I switched up the script on this character so that it used add just force, then we will not be probably seeing this problem. In fact, I bet you if I actually do that, somewhere in here is the platform controller, what is on the ground, air control. Okay, never mind. That was not as useful as I thought. Okay, well, anyways, so that's a way of, like I said, creating sort of like a water-like effect right here. There was one more effector that I actually don't know much about. So this is venturing new grounds. We're going to, oh, not used by composite. We're going to use a new effector. And then this effector is, we can also just search it, effector. There's a Buoyancy Effector, which is literally water, Point Effector, and Surface Effector. Surface Effector, Collider Mask, everything. Ah, okay, yes, I do know what this is. Let's make that 10, speed variation, let's make that 1-ish, force scale, option, use constant force, use friction, and use bounce. All right, oh, whoops, that's not what I meant to do. So this way, if we lower this, nope, nothing is happening. I thought something would happen if I do that. I should also make it so that this camera actually follows. Camera 2D follow, there we go. Let's make sure that this follows our good old character robot. Right, so what does this effector do? I got the right one. Speed. That's not the reason. Use collider mask, constant force, friction. You can also click on this question mark book button, and that'll bring up a browser on exactly what that item is actually supposed to do. The surface effector 2D applies tangent force along the surface of the collider used by the effector in an attempt to match a specified speed along that surface. This is analogous to a conveyor belt. That's what I thought. I thought this was a conveyor belt. Oh well. Collider you use in the effector will typically be set as non-trigger so that other colliders can come into contact with this effector. I don't especially know why. Yeah, I'm not going to pretend I know why this is not working the way I originally expected. Strange. Collider mask is set to everything. Moving on. Awkwardly, that is. Point effector. This needs to be set to effect. This also needs to be checked. And then force magnitude variation, force source, force target, force mode, damping. This I actually literally don't know what it does. Applies an attraction and repulsion against a source point, which can be defined as the position of the rigid body or the center of the collider using the effector. So the force source. So the target, I would assume, would have to be the collider itself. And so if we do that, oh yeah, you can kind of barely see it. So we'll expand this. Woo! Oh, whoops. Woo! Okay. Yep, you can see it. I'm being magnetically attracted towards the center of this platform. So that kind of allows you to create some magnetic / gravitational force. And I believe the last but not least, buoyancy effector is literally the same thing as the water effector. Oops. We can get rid of this area 2D effector and then just add in the buoyancy effector right here. Damping, flow. Oh, there's a flow. Interesting. So, anyways, Oh my goodness. What have I done? Oh, this finally kicked in. Alright, so I'm being magnetic attracted to that. And then this should be the collider. Yep, this is the collider. You can kind of see the graphics right here saying that this is where the surface is. If I can raise that surface level up a little bit, there we go. So that kind of encourages the player to always float towards a specific horizon. So that's 2D effectors. Some pretty cool stuff that you can do, largely with just plain old physics manipulation. And then we can get rid of these manuals because, of course, I don't know what I'm doing. Navigation mesh. There's actually a little bit of AI that you can actually create with Unity. So, for example, oh, whoops, what is going on here? Oh, I pull on the 2D right here. So one thing that you might notice is that once you go through the standard assets, one of them is, I believe, called agent. No. Third. Okay, here it is. So there's a prefab called AI third person control. If you import assets, import package, and then characters, and if you drag and drop that, what you might notice is there's this weird cylinder appearing on top of this character, and it will ask you, oh hey, you know, you can make this target, you can make this AI character control target a specific thing. So you might think to yourself, okay, well, I'll have it target this third person character that I'm controlling right now and try to play it, and absolutely nothing happens. In fact, if you bring up the console, right now it says set destination can only be set on an active agent that has been placed on a nav mesh. Get remaining distance can only be called to an active agent that has been placed on a nav mesh. So what the heck is this nav mesh thing that we're talking about? Well, as it turns out, it's actually fairly simple to put together. Nav mesh can be opened by going to Windows and then selecting, I believe somewhere in here, nav mesh. Where is it? Navigation. Yep. So towards the bottom right here, there's navigation. And then up here on the right side, if you click on it, it'll give you a list of objects. Right now, if you set to all, seems to be looking for, yeah. Select a mesh render or a terrain from the scene. All right, well, let's do that. Let's select, let's pretty much select everything. There we go. So you have to highlight everything, and then you have to let it know, hey, these are the objects. We want to make it so that you can actually navigate on all of these. Well, we can do that by just clicking on navigation static under this. Generate off mesh link. Sure, let's do that. And then make sure that we set it to either walkable, not walkable, or jumpable. We're going to switch it to walkable. And then we're going to let it bake by clicking on the bake button up here and click bake. And you might notice that this is the new graphic that we're going to see. So what the heck does this do? Well, as it turns out, when we now play the game, there we go. We got a character that just follows us along, even though it's graphically a little complicated and it's having a really hard time right now. But you can tell that it's trying to get to us by actually trying to base towards that direction. Let's put that in the different scene right here so we can actually see what's going on. Here it is. You can kind of see in this scene that, yes, there's a character that's kind of tagging along wherever we walk. So we can actually do a couple of different things with the AI third character here, which is that you can adjust, you know, their turn speed, how quickly they run. In this case right now the speed is set to 1. I'm going to make that half that. And then that should, in theory, make them a little slower. Yep, there it is. They're now walking. And you can see here on the other camera that they're obviously being a little slower. This is actually kind of important because as it turns out, there's a couple of different things that we can do extra that actually is really useful. As a quick example, I'm going to look for a specific floor right here by typing in floor. And then there's a couple of different floor prototypes that you can find. And then I'm going to take that out so that I can actually see which one's prefab and which one isn't. I'm going to go for this one and just kind of drop it right here. If we drop this item right here, and then I'm going to set this to trigger, there's a specific reason why. And then when I click on navigation, so yeah, right now this is kind of marked because we already baked it earlier. This is kind of marked as, hey, you can do stuff. This is not marked as something that you can navigate to. We will set this to navigation static, generate off mesh, and then navigation area, walkable. That looks fine. Set that to bake. That does not look like what I wanted. Let me lower this so that you can actually walk on top of it. Bake it again. There we go. So, okay, yeah, we have this floor right here. We can walk, well, we can walk right through it, which is kind of not very important. Our character is having a hard time getting up that. That's interesting. Maybe because we set this to trigger and that was probably a bad idea. Let's untrigger that and see if baking does anything. Let's lower this also as well. I just want to make sure that I can actually get the character. Okay, so the character is able to make it on top of this platform. Good. This is actually kind of important because, as it turns out, one of the things that you can adjust on these is the navigation area layer. I believe when you click on the layer, it says walkable, not walkable, and jump. When you click on areas, you might notice that, hey, look at that. There's a bunch of different user-related items that you can toss in. This might probably remind you of the layer UI, and in fact, it is exactly the same thing. I can make this the super slow layer, and then I can also adjust the cost to say this costs 10 units to walk through. So now if I select on this object, and then I say, instead of walkable, I want you to be super slow, and then bake it, you might notice that this portion on the navigation mesh appears in a different color. As it turns out, if you do set it that way, and then if I try walking towards it, well, first off, our character is literally just going to try walking towards that, and I don't know why they're having a hard time, but they're going to do so. They're still having a hard time. Interesting.
Decrease the step height in the instructor window?
Yeah, that's probably one of the reasons. So where is it? It says.
So it did 24. Can you increase that and make it higher? I don't know if that's wrong.
All right, but what matters is actually the fact that first we need to be able to see this character. All right, if we walk off of it, you might notice that the character is actually going to attempt to walk around this, or maybe not. Yeah, I don't know what's going on with this character. Okay, but in theory, what's supposed to be happening is that that extra layer added a cost to this specific different colored area. In doing so then, what that causes is that it causes the recalculation to happen. If you can imagine, for example, that this is supposed to be a swamp rather than a normal solid ground like this, then you can kind of use that different layer scheme as a way of forcing your AI character to recalculate and think, oh, okay, because this is a swamp, I'm going to travel a lot slower if I go in that direction. What if I took a different path that will be a lot faster? So like I said, you can add a cost to going to a specific location, and what it will do is it will cause the AI to recalculate and think to itself, okay, I need to, that's a swamp right there. It's going to be really slow for me to traverse that. I should try traversing in a different direction and calculate as such. One last thing that's worth talking about, and it's actually a lot harder to do than I like to admit, is the creation of what's called an off-mesh link. If you create, in theory, I'm going to create a sphere so that I can actually have some sort of visuals. Where is it? Okay, cool. So what I'm going to do is I'm going to plop this sphere right up here. I'm going to get rid of this sphere's collider because we don't need any collision. This is just here for graphical purposes. And then I'm going to add under components, there should be a nav mesh obstacle, and then what is it? Link. Off mesh link. So right now, off mesh link asks for a start and an end. I'm going to drag the sphere itself here. I'm going to duplicate this sphere, plop it under there. Get rid of this off mesh link, excuse me. That was probably a lot more complicated than it should be. So this, I'm going to name this sphere to start link. And then for the other sphere, I'm going to call it the end link. And under the start link, I'm going to set the end link to the end right here. Cost override -1, bidirectional. It is not bidirectional, it is single directional. Auto update position, make sure that the navigation is walkable. That sounds good to me. And then we're going to drag this sphere down to right around here. So now that we created this off mesh link, this is just graphical purposes only, and then we should be able to then provide a bake. Okay, that didn't quite do what I thought it did. Oh, no, it did. You might notice there's a very faint line here. It's hard to tell, but there is a very faint line right here that says, hey, you can jump from this direction down. So that is actually kind of useful, because if I walk up here, and assuming that the AI cooperates, it probably will not. All right, the AI is coming. Maybe not. So what is supposed to happen is that with an off-mesh link, that creates what's called a jumping point. So you can make it so that your character jumps from this point down to this point that we've created earlier, right here. So now, in theory, rather than trying to walk around, well, that's, I guess, one short way of doing it. You can also make it so that the character kind of goes up the slopes and then jumps down to try chasing after your character. All right, so it decided to walk around instead. I still prefer the stairs. Okay, I glitched Unity. Good to know. Well, we're going to need to file a bug. I didn't know you can do that. I guess there's a first for everyone. But I swear, off-mesh link works. All right, so that's navigation mesh. And finally, built-in shaders before I talk about other features. I don't think I have a scene for, no, I do have a scene for shaders. Built-in shaders. right here. So you can see a bunch of cubes right here if you play it, or a bunch of spheres, excuse me. And if you play this game, you know, you get to kind of see what those spheres look like. But there's actually, whoops, we don't need this asset store. As mentioned earlier, I asked that you try to import packages and effects. That does, in fact, create a couple of new things. If you go to the standard assets and I believe effects, you'll notice that there are now a couple of different options, including Toon Shading. So let's say, for example, that instead of this sphere looking like the realistic sphere that it did, we want to make it so that this sphere looks like a cartoon. Well, there's a simple way of doing that. You can just right-click and say create new material. We're going to call this Toon. And we are going to drag and drop that Toon onto the sphere. Nothing happens so far right now, but if we click on this Toon, go to our inspector pane, and then say, well, we can want to expand this and kind of change this. There's different sets of shaders that you can kind of decide on. One of these include if you haven't worked with the standard shader before, I highly recommend doing so. This is the color right here. You can also change the texture of said color so that that will look like this. You can also change this. We need to take off that. It's a none. You can also change the metallic value of it so that it looks like it's reflecting more. We can also increase the smoothness of it so that it's kind of looking like it's reflecting even more. Right now it's set to only reflect off the skybox. I'll go over into figuring out how to fix that. There's normal maps and height maps, which I don't have many examples of. What's a normal map? Oh, we have an Ethan normal. Good. So we can drag and drop an Ethan normal map on here. This is going to cause it to look a little more bumpier than usual, and you can adjust this normal map to make it even more bumpier than it should be. That subtlety I kind of like, so I'll leave it at that. Height map, occlusion. You can also make it so that it emits the light. And of course, it is the way it's going to look like if you tell it, oh yeah, this thing is supposed to emit a little bit of light. Let's make it a little more natural-ish color. Make sure that its intensity is a little lower. So on and so forth. So there's a lot of things that you can do just with a standard shader alone. So yeah, that's looking nice. Also, Toon is a misnomer, so I guess I'm going to change that name to Reflective. Reflective. But yeah, I mean, that looks nice and all. Also, just because I'm a bit of a jerk, I'm going to also create a camera here and make sure that, okay, that camera is rendering the same thing. Drop that render texture, see if we can see the albedo changing on this. No, it doesn't look like it. Oh, we didn't set the albedo. That would explain a lot of things. So we made this super metallic and super smooth, but if you kind of reduce it, we should see a faint outline of what we're actually seeing. Now, this is just me being silly. We can actually make this so that it actually reflects the surrounding rather than using a render texture. But anyways, so besides that, so that silliness aside, if you want to make the reflective actually reflect things, then what you'll need to use is what's called a reflection probe. So here, you might notice under lights, there's a couple of different things, including, most important of all, reflection probes. So if you create a reflection probe in the scene, you might notice that here, that kind of blinked a little bit, but it also creates this little cube right here, and it also created this little sphere. So we're going to create a couple of these. I'm going to also create empty so that I can organize this properly. This game object, let's plop this at 0, 0, 0 for now. Let's plop this reflection probe also at 0, 0, 0 for now, but also we need to raise it ever so slightly upward so that we can have like a proper reflection going on. And then let's duplicate this and just kind of space it out evenly. And then let's create a new set of these reflection probes, place it right here, and another set of reflection probes, and place it right here. So now, what did that do in theory? What that did was that each of these reflection probes should now be depicting what the surface area of what this object is supposed to be reflecting. That didn't make a whole lot of sense. Bounding box, that looks right to me. Yeah, there's a lot of overlap, so that's good. Okay, then we got all these reflection stuff going. It says bake, but what does that mean? Well, as it turns out, if you go to window, and then if you go to lighting, and then I think it's just settings. Yeah, great. So I'm going to drop this right here. There's a couple of different options that we have. Sun source, we should probably set that item 2 to directional light, blah, 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 blah. And then it says auto generate. That should be good. Real time mixed lighting, shadow mask, global maps, object maps. Strange. Baked indirect? No, that's not the reason. What happens if I uncheck that? Oh, great. So it's right now baking the reflection probes. You can see the, alrighty. There it is. I don't know if that did much, but we should be able to now play it. That actually did not do anything. It's supposed to, which is strange. Light probe group. Don't need to worry about that. Anyways, in theory, what's supposed to happen is that with these reflection probes being created, this is actually supposed to show a reflection of all the items that it's actually being reflected towards. So for example, right now all it shows is a skybox, but it should actually depict this floor as well when selected, which is why I'm a little baffled as to the reason why that's not actually showing. And I'm a little confuzzled by that.
Feedback from Twitter.
Huh?
Feedback from Twitch. Maybe you just need to set it to static.
Ah. Yes, children. So I did set it to static. Oh, you mean all these things. Got it. So, thank you. Yes, I did forget a step. So I'm selecting all these spheres and the floor right here. You might notice that when you in the inspector, there's a checkbox called static. If you just kind of click on the little arrow, it says a lot of different things. I'm going to go right on ahead and just say everything. So let it do its job. You might notice that there's a little taskbar, process bar on the bottom right hand corner that is currently processing and trying to figure out what it needs to do. Just kind of let it do its job for a minute. Maybe it's taking a whole lot more time than I'm expecting. Strange. But anyways, in theory, what that does is then it has all these reflection probes calculate exactly what the reflective area is supposed to look like. And in making that calculation, it then creates a map of what the reflection, of how things should be reflected should look like. I think we actually don't need that many reflection probes, so that's the reason why it's kind of being slow right now. Let's just get rid of, one of these rows. I don't think we're going to need this row. And then I don't think we're going to need these two either. So then that allows us to kind of move these reflection probes to just right here. And then maybe if we save that, then that should cause it to be a little more nicer. All right, here we go. So now if I click on this, you might notice that, hey, you can actually see the reflection of these different spheres. So it baked that information in. And now if I get closer to this, it does, okay, it does sort of reflect the spheres, but in kind of the wrong direction. That tells me that we need to scrunch these reflection probes a little closer to the actual sphere itself. So here, is that submerged? No, it actually is right up there. So this needs to move up a little bit, like right here. This needs to move up a little bit right here, and this needs to move up a little bit right here. So there we go. It kind of gets the reflection right. It'll probably make more sense if we get rid of this normal map out. Oh, it's recalculating. There we go. We should probably take out the emission portion of it too. Yeah, we should probably take out the emission. Anyways, so you can kind of see how that can be used to create basically a reflection of what each of these spheres could possibly, what each of these spheres look like. I did kind of digress a little bit. When you create a new material, there are a couple of different options, including switching up what the material itself would look like. So I'm going to select this. I created a Toon shader right here, and then from here I can switch it so that.
I think according to the guy on Twitch, you just need one reflection probe on top of the reflecting sphere. According to the guy on Twitch, you just need one reflection probe right on top of the reflecting sphere.
Yes, that would actually make a lot of sense. There. Oh, whoops. Anyways, so the second item, we're going to select this. You can change this standard shader to basically other sort of shaders. There's apparently an AR shader, which is actually good to know. GUI shader, so on and so forth. But there's also this Toon shader. So we're going to change that to say lit outline. And if you do that, it's going to look a little flat like this. But that is totally fine because we just need to apply a Toon ramp texture. And there's a couple of different ramp textures that you should have been able to import in a parent. Oh yeah, here it is, util Toon gradient. So we can select that. Then you might notice that this kind of looks a little different. Main color, I'm gonna make it a little grayer so that you can actually see the Toon shading going on. And furthermore, there's an outline color. We can probably make this outline a lot thicker. So if we actually play this in game, Well, that looks kind of different. So Toon Shader, as the name implies, kind of creates this very toony, like a cartoon or cell shading like shader system to it. It's fairly simple. I personally like using the Toon Shader a lot, so that's usually something that I highly recommend utilizing. Here's yet another sphere that we can probably use to play around with even more materials. So with that in mind, let's create another material. There's a physics material right here, but let's actually grab a new material. Let's call this unlit for now. I'm probably going to change my mind about it. And then there's a couple of different unlit shaders that exist. Unlit, as the name implies, there's just no shadows applied. There's color, which allows you to just change the color of the shader itself. Or just change the color. So like there's not even a shadow. Like it's just a flat color. You can also choose to use instead whoops, where is it? You can also tell it to use a texture instead. We should probably switch that out. Let's say this one. Yeah, like this one. So it just kind of looks flat regardless of which direction you're looking at. So on and so forth. And then finally, this one. Let's give this some new material. Unknown, because I can't decide. And then let's say this, for this material, there's tessellation, interesting. Oh yes, there's projectors too, I could talk about that. And then there's a couple of different items here. Gui Effects, Custom, and AR. Okay, yeah, there it is. This will be useful. Cutout. I'm gonna go with just normal diffuse for now. Unless there's a cutout somewhere and I'm not paying attention. Oh, I think the standard shader does have a cutout. Nope, I am wrong. Really? Oh, here it is, transparent cutout. So this one, you know, the item doesn't have any transparency to it. Let's see, what's a good one that does have? Huh?
It does have a cutout. Just change it to random node to cutout. It's the drop down below.
Which one? Where's cutout? I'm not seeing it. Oh, right here. Okay, good. So this is cool. So I'm going to take a quick look at this, make sure that that's applying on the right place. And then if you play around with the alpha cutoff, you might notice that it suddenly starts cutting out this shape right here. It's based off of what the albedo shape is. So in this case, the texture happens to be this camera shape, but I can switch that out to other different textures, and you might notice that you'll get a different, basically a different shape here. Cutout is really interesting because you can kind of use this to create sort of like a door open, or like a particle effect, or some sort of like wacky effect to make things appear and disappear. A good example I can think of include, for example, like when a character dies, then you can have it so that they melt, and this will be like a really easy way to create a melting shader, melting like effect shader. So yeah, so definitely play around with a couple of different shaders and see what sort of effects that you personally like. Like I said, Unity comes with a couple by its own, and they're all kind of useful in their own different and unique ways. And finally, I wonder if I have time for this. Oh, I skipped one. Haha, particle systems. So yes, I did actually have that scheduled at some point. Here it is, particle systems. When you play this, yay, fireworks. So this is taken directly from the standard assets. When you look for inside this project right here, fireworks, you might notice the single prefab right here. This is exactly the prefab I simply dragged and dropped into, and this is the plain old, plain old fireworks particle system that we have playing. But there are a lot more that you can actually do with this. They recently created a bunch of new features to it. You can kind of see this actually being played around right here. And I'm only going to go over, because I am very close to overtime, and I want to make sure that we have a little bit of questions. I'm only going to go over some of the more cooler stuff that they've recently added in, which is when you go under and go to the very bottom, there's something that says render right here. And it'll say like, hey, you can render it as a billboard, or you can render it as mesh. And so I'm thinking to myself, well, cubes aren't fun. Let's make these spheres. And then rather than this, particle effect that we have going on, or particle shaders that we have going on here, hey, coincidence, we were just talking about materials earlier. Let's create a particle shader. And then let's make sure that this is an actual particle shader. Let's switch to additive soft. That looks right to me. Maybe make it in a camera or something like that, and then go to our own fireworks again, and then replace this with our stuff. So now we have, I don't know what we have. Well, we have bubbles. You can, in fact, do a lot more with this. For example, the bubble effect probably makes more sense if you're doing something like, say, creating a smoke-like effect. Yeah, there we go. This probably was a bad texture. There we go. Much more like it. So there's that. We can probably go over these trails and Afterglow. Okay, so you can kind of see that they have these little Afterglow stuff as well as these little trail stuff. I believe they actually added in a new trails render, so you can add in a checkbox right here, and voila, we already have something that looks a little wacky. Assign a trail material in the render module. Yes, good question. So let's grab a material and let's call this a trail, and let's make sure that we grab in particles trail renderer. I guess additive soft might work. It probably will not. Go to trail. A trail renderer in the renderer module. Yep, right here. That's a particle shader. We didn't want that. We wanted trails. There we go. And then for trails, we're going to give you time clock. There we go. Yeah, look at that. Look at all those clocks spouting out. So the trail renderer is actually more useful for creating a smoke-like effect. So you might have this rising smoke trail going up slowly. But yeah, now there's trails. I'll definitely highly recommend going through all sorts of different features that exist in the particle system. Again, it's already 8:43 and I don't want to go too far into overtime. So those were the couple of different new features that they added in for the particle system, which has like a ridiculous number of features, including adjusting based off of how quickly something is moving, how much having more particles being emitted right after a particle dies, so on and so forth. Other features, these are a list of other features that I wish I had time to talk about, but I simply do not. With an exception of reflection probes, apparently I had exactly the time to talk about that. But these are the couple of things. Animators, a flowchart for animations. This is actually an excellent point to kind of bring up, let's say, for example, the 2D effectors. Let's save that. For animator stuff, you can bring up the animator window. And then in this case, I am going to just kind of have this flowing, honestly. And then make sure that I select, in this case, the character robot. And then the animator window works as follows. If you're paying attention to this graph right here, you might notice that right now this idle node is right now playing, but as I switch to running, then it switches to the run node and so forth. So each of these state actually acts like an animation that is currently being played on the character itself. And so in doing so, then you can create this workflow of which animation is supposed to play, and then using these parameter values when they're supposed to play, and so forth. Going over this is actually super complicated and could be a full day's worth of effort, so I'm going to skip over that for now. Timeline is a recently new feature that they added in. Timeline is intended to create basically cutscenes, in-game cutscenes, by stacking animations on top of each other, including camera animations, for example. There's the input manager, which you can access by going to edit, and then it's project settings, and then in here input, and that gives you a list of all sorts of input items that you can change. I believe also they recently added in under the player an option to, yes, here it is, active input handling. There is now an input system. Unity editor must be restarted before this change to take effect. No, let's not do that. So there's also now a new input manager that you can use to check to see if there's multiple, I believe it handles multiple controllers, and you can also make it so that each of the buttons can be remapped to very specific actions. So that is right now in preview, but those things exist. Reflection probes, bakes reflection. Light probes. Light probes technically is not necessary, but my understanding is that for mobile devices, this allows you to create a more efficient color bleed system. Actually, now that I think of it, it probably is necessary. So light probes is basically used for what's called light bleeding, color bleeding, which is that if you're standing right next to a red block, chances are, if it's a well-lit location, then your clothes should look a little more reddish because you're standing right next to a red block, and the reflection of that red block causes your clothing color to also reflect the same thing. So light probes is useful for that specific purpose. Acts just like reflection probes. Light mapper, that's a more efficient way of baking shadows and color bleed. It takes way too long to actually put together that one. UGUI is a new GUI system. They have now a new GUI system that you can actually get started in creating. I'm going to go with cameras right here. It's fairly simple to get started on. You just have to click on right click and then say UI, and then you can choose a button. And in theory, that created a new button right here. I guess it is confused as to figuring out where to place that. Yes, it is very confused as to figuring out where to place that because there are multiple cameras right here. But in theory, when you click on the canvas and, oh, it says right here overlay, so it should just appear. Oh yeah, it is right here at the bottom of the screen. That is not a very good place to place that, so let's make sure that that is actually placed in the right place. There we go. We got it. We got a button. So yeah, Unity now has a proper GUI system that you can use. Tile maps. This is a way to create maps in using a grid by using a technique called tile map. I have no time to talk about this, but it is very powerful. It is currently a little rudimentary, but I believe over time it will become more and more complex and add more features. Audio mixers. This is awesome. It allows you to blend and mix audios together. It also allows you to create sort of like a cool global pitch and global volume control. So you can also add in different sort of audio effects, such as if you want to make it so that when you pause the game, the entire audio just kind of dims out and you can't. The volume kind of lowers. There's an effect for that. There's some effects that you can add in where it sounds like you're talking through a radio, so on and so forth. AR and XR editor. This allows you to preview any sort of AR or VR or mixed reality games. Analytics tracker. There's a script framework, excuse me, that is the word I was looking for, that allows you to just kind of keep track of certain analytics and data, and you can ping that to Unity and say, hey, can you record this on your servers, and they'll let you do so for free. And there's a lot of plugin support. And speaking of plugins, you can extend the editor too via plugins. And here are a couple that immediately came to my mind that I thought was really useful. The nav components is a recent new item where so when you look through the whole nav mesh thing, what you probably didn't know was that you cannot actually recalculate those nav mesh in real time. So if you have moving platforms and you want to make it so that your characters can jump over that, well, tough luck. The current system does not allow you to do that. The nav mesh component allows you to create nav meshes on specific components themselves, so that if you actually do end up moving it, then you just have to run a function that says recalculate the nav mesh, and it allows you to recalculate and have all the characters basically run after you, taking into account that the layout looks different. Scriptable render pipeline is used to use C# as a way of scripting how the graphics gets rendered. This allows for you to add in new effects such as mirror effects, refactoring, so on, refractions, like the windows, so on and so forth. But more importantly, with that comes the shader graph. There is now a visual shader editor available for the beta that's currently out right now. And you can actually kind of play around with that and create your own shaders. Toon shaders, I heard, cannot be made with the shader graph, which makes me super sad, but that is coming into the loops. Post-processing. Oh, actually we can talk about post-processing because I happen to have post-processing installed on here. Let's see, this is the main camera. Nope, that's the wrong camera. The multi-purpose camera rig, okay, perfect. So you can now add in some post-processing effect on here, in theory anyways, post-processing behavior. If you right-click on this, or if you click on, I believe, component game objects, I might be wrong. Assets. There we go. There's a post-processing profile. So we're just call this profile for real quick. And then going back to our camera where we added that post-processing, we just need to drag and drop that profile here. And so when you add that, you can add in a couple of different new effects on here. I don't want fog. You can add in, for example, depth of field and motion blurs. And in theory, that should, okay, depth of the field is too subtle. Bloom. There we go. That's a lot better. Let's make bloom super intense. Awesome. All right. Eye adaption. Okay. I guess that's user LUT. You can use level of. I forget what the acronym stands for, but LUTs are ways of kind of changing things to look a little different. I don't know why that happened. I guess we're gonna find out. Oh, it says so right here. Invalid fix. There we go. Wow. Oh, here we go. Red, blue. This did not do what I think it did. Blue, red. Purple, green. Let's do that. Fix. I don't know why that's not working as intended. Yeah, I don't know why the LUT is not working as intended, and the eye adaption is probably a little too much. We should be seeing motion blurs. I'm not seeing it. Not seeing the motion blurs. Motion blur, shutter, frame blending, sample count. Okay, let's try that. Oh yeah, there we go. That looks like motion blurs to me. So yeah, you can add in a couple of different post-processing stuff. I used a really simple version, but there's actually now a new editor version for it, so that you can add in some more post-processing. Look up textures, thank you. There. Totally exactly what I had in mind for this game. Anyways, before I go way off track, there's now also a machine learning agent editor, which, as the name implies, actually creates a little AI system for your character, and you can kind of teach it some behaviors by kind of playing against it. And after playing against it for maybe an hour or two, it'll eventually become smart enough and start doing some crazy, wacky tactics. So that, again, the GitHub links is up there. I highly recommend checking that out. Cinemachine is crazy. It gives you a very cinematic way of animating your cameras using all sorts of different techniques, including dollies, focus points, focus location, so on and so forth. You can even add in some camera shakes in there, shaky cam, all sorts of fun stuff. And then there's also Anima 2D, which is a fairly recent skeletal 2D animator included in Unity. Excuse me, it's not included in Unity. You'll have to go to the asset store to get it. But it allows you to create actual skeletal animations for your character right from the editor itself. Steam Audio, this is created by Valve, allows you to map walls such that audio effect will actually bounce off of them, creating these echoes. So there's an actual application for that specific purpose rather than just using reverb zones. And new and hot off the plate, also, there is, according to Unity's own blog, I think it's blog.unity3d.com. Nope, that's not important. Nope, none of these are important. Where are you? Ah, here it is. Pro Builder. Pro Builder is now free, and it allows you to create meshes in your editor directly. I also realized there's also now a new terrain creator that you can just create on a 3D object. And, okay, so there's a graph builder that they're completely skipping over. And I believe there is now an asset on the asset store that allows you to export all of these in an FBX file as well, which is again also free. So yeah, you can actually start doing some quick level design prototype so that you can start constructing some levels, and then using the FBX exporter, you can toss that to your artist and say, hey, make an environment that approximate this collision, but looks a little more prettier than that. So yeah, there's a lot of really cool tools that you can add into Unity. That's all I had for presentations. If there are any questions, please let me know. Any questions? I have a question to you. What do you think of this presentation, and do you think it was pretty useful? Cool.
Yeah, I enjoyed the camera stuff. Personally, myself.
Huh?
I enjoyed the camera stuff quite a bit. Just because I haven't played around with cameras a lot, so I still learn about the different ways to do it and the trick.
Mm-hmm.
What version of Unity was that?
I was using 2017.3.
What is it, standard or pro?
Regardless of whether you use standard or pro, they have exactly the same set of features.
Really, it's the licensing differentiation?
Nope. The free version has exactly the same number of features as the pro version.
I know you pay it up. Is that really the difference?
The difference is you can only make you only sell so many copies before they say you have to upgrade to so you make no money with it, or you make not a lot of money. I think it's like up to $100,000. Then you keep the free version, but then over that they already asking. So
I think it was actually like 100. I don't remember the exact number.
I think it was 100,000 something to that effect. The other difference is you get a lot more online services available to you. So their licensing is about having more access to the services. But if you're talking about the editor itself, the editor, the pro version and the free version have exactly the same set of features.
Is it desktop app?
Yes.
yeah, with that, I think the source control, right, the free version really allows up to 3 people working on a team, and then you can pay to get more.
I haven't really talked about what you can export to, and I don't think, okay, yeah, you can actually export to a ton of different platforms. I didn't know you can export to PS Vita. I learned something new. You can export to Android, WebGL, iOS. You will have to pay specific license fees for Xbox One, PS Vita, and PS4. You can set it to the Universal Windows platform and also to Facebook.
So for the record, it looks like the free version is obviously free. You can only use it up to $200,000 in of income in 1 year. Then there's a plus version, which doesn't seem to change the amount of income you can earn off of it. It just seems to have more stuff. That's $35 per seat. And then the pro version is $125 per month per seat. But it seems to have even more than the plus version and allows you to make as much income as you want with that license. Whereas with the personal plus, it looks like you can only make $200,000 in 1 year before you're really supposed to upgrade to the pro version for the next year.
So the code that this editor generates has to be specifically ported to a platform, store, and then downloaded to an edge device. So it always runs. Does the game always get played on someone else's hardware device as well as played on the cloud?
You can cut it out. You can import it or create it so that it's on a web.
You could.
Browser
Yeah. I haven't talked about it, but there is a framework for network stuff. I'm not a huge fan of it, but you can. Let's see. I should have also mentioned that you can build directly to Android. I don't think that requires any license. You can build to iOS if you have a Mac. That is the main restriction behind that.
There are a lot of challenges about building iOS, though, beyond
Yes.
actually running it.
It is not recommended to use iOS as your first developing platform. I would recommend Android instead by a mile.
Is this product one of the Goliaths of the game design industry, game design development industry?
It's definitely considered one of the most prolific. I will say that it is often the mobile developer's choice.
I think when you get 3D engines, you really get Unity and Unreal. I don't know if there's really anything else that compares to that as far as popularity.
Mm-hmm.
3D engines, you get much more of a spread.
Lagging significantly behind it is Godot, but that is because they just recently released a new version, and far more importantly, is more for anyone who's really like open source fanatic, and they refuse to buy anything that's closed source. It is possible to get the source of Unity. You need to talk to them. It is not cheap.
Thank you. That's all.
Unreal's source is, I believe, exposed, but I don't remember what their licensing is like with that.
If I remember correctly, for their source, I don't know. If I remember correctly, for Unreal, we basically give them 5% of your revenue.
Right. Oh wait, let me see. With depth of field, I bet you. Okay, so the focus distance is 10. Let's make that to like 5. And then.
Amazon Lumberyard? Yeah. Amazon Lumberyard. Another, I'm not looking at it, but there's another game that is.
Yeah, that depth of view didn't do as what I thought. Screen space reflection.
I want to play this game now.
It did turn into quite the aesthetic experience.
Yeah.
That was, John implemented it on real agility.
Bring this in. When we did Unity, we had to build a game.
Yeah. Stay tuned.
Is there a module or interface to use mathematic algorithms to drive the input as opposed to, say, a keyboard or a swipe? So 1 makes it do this, 2 makes it do that, 3 makes it do this, and that's all done by a random number generator?
That would involve scripting.
That's the most, okay. But
Yes.
that's built into it, these abilities to do that?
Yeah.
Why don't you open the script real quick?
Like the roll, like simulating the roll of the dice, or random number generator, you can do that without looking at dice.
There's a full language behind this, full computer language behind it. So,
Is it a proprietary language?
now C#.
It's C, oh, so you would do your scripting with C?
In C#, and you mostly see this is just these little interfaces and stuff, but if you really do anything, you have to script a lot. Taro, would you like to open up the script so you can take a look at it?
Sure. Let's take
How
a.
you do the matter, just
This is not a script. So,
We use our core activities on Twitch, like our lesson. Maybe a lesson.
I didn't quite hear that.
Our Twitch viewer liked the lesson.
Nice. So here it is. This is what the scripting looks like. You gotta make sure that this has the same name as the file itself, but other than that, this namespace you can completely disregard. Oh, interesting. So this script doesn't actually expose any variables, but if you type in, for example, serialized field, and then type in, like, say, private int state, save that, switch to this, then right here under the script, it should now then create a new variable, state, and you can change that number to whatever you like. Now, if you want to change that in real time, that's a different story entirely, but yeah, you can do stuff like that.